Hi, I'm Steve Barsick Amstel with High Tech Design Safety. We're a third-party evaluation, certification, and testing firm. We're also notified or certified field labeling company. I'm here to continue our training on CIMI S2. And I've gotten some great questions about CIMI S2, and I'm going to deal with those in the next 3 videos before we jump back into going over each section of S2. So the first really great question was what to expect from the process. And for doing CIMI S2 testing, let me back up a little bit even before what to expect from the process, but how you can make your process easier. First would be to start out having done this training, which would be great. In fact, we could deliver this training on site to you and your team in a 1 or 2 day format, specifically focused on your equipment. Several of our clients have taken that on and found great gains in reducing time to market, time for the CIMI S2 inspection process, and the costs as well. So number 1 would be to have your team trained up on what's required in the standard and how to design the equipment to meet it based on your hazards. So once you do that, and oh wait, let me back up for one other thing. It's great if all of your engineers have access to these standards. Now, I know that seems self-evident, but a lot of times we get ahead of the game and don't buy the standards and train the engineers on the standard so they can design to the standard to complete the standard. Additionally, for CIMI S2, the other big thing that you need to look at is designing the electrical parts of your equipment to meet a particular electrical standard. We highly recommend using IEC 60204 as an electrical standard, or IEC 61010 as an electrical standard. And then also using NFPA 79 for industrial equipment electrical standard. If you encompass the proper ones of those 3 standards, pick any 2, you're going to be really, really happy with your outcome. So having the standard, doing the training, and then of course designing the equipment to meet CIMI S2 and meet those other standards. Further beyond that, you're going to have other additional hazards. Just today, I was asked to certify a piece of furnace equipment for a semiconductor use. Well, those furnaces also need to comply with other standards. So take a look at what you need. We can help you scope it, and then you'll have the standards and be able to design to them. So once you've designed to the standards, here's the next things you should expect from us, or any lab doing your testing. From you, we will get as much data from you as we need in order to scope your evaluation. So we need to figure out how much power is coming into it, how big it is, meaning how big is the electrical cabinet, to give us an idea of how much time we need to work with you to do a conformity discovery process and know that it's designed properly and the proper components are selected. Once we know how big it is, then we also want to look at what are the other hazards. Like I mentioned, is there heating? Might there be lasers? Might there be X-rays or radiation or toxic chemicals or pyrophoric chemicals? Each of these other standards requires us to spend more time doing testing and evaluation. So once we have all that together, we together with you will have developed a full scope of what we need from S2 and from these related standards to give you a good result. Then once we have that information, now we can quote you. Now here's the neat thing about High Tech Design Safety is we've done, gosh, I don't have the exact number. We're getting close to 1,400 evaluations in the history of this company. And for us, that's an exciting number. We'll let you know when we hit that and look down in the comments to see where we are now. And while we're scoping it, we want to be clear that we know how many pieces of equipment you actually have. This is very common for us to get on site and not have one piece of equipment, but maybe 2, 3, 4 pieces of equipment. And it's very difficult for us to have scoped the time on site to match 4 pieces of equipment much less match the level of effort that we're going to need to give you a good outcome. We really need to get an idea of how many pieces of equipment it is. Two quick examples. I was out recently, within the past few months, doing tracer gas testing, and instead of one piece of equipment, it turned into 4. It made it very difficult to fit even the minimum amount of testing into that test plan. We went from a very well thought out, easy test plan to having to push all day long and work a 12-hour day, and still we wished we had more to give a better result. We got it done, and those additional pieces of equipment and that rush service doesn't give you a good result, and it makes it hard on us, and it's an increase in scope. Another great example is I just got off a project, landed here in Austin yesterday, and it went from 1 piece of equipment to 3 again. And I had to be straight with the client and say, look, we want to give you the best possible result, set up the next 2 pieces of equipment for additional evaluations, and we're going to get it done for you. And they were so thankful. We got their first piece of equipment through. They're going to be able to go ahead and ship once they make the design changes that we saw, 1 design change, and get it done. So the next thing that you'll see is a quote from us for the effort to do the evaluation. Then what happens is we'll request more information so that we have a full design package to review before we come on site. Then we'll set with you a schedule to come on site. We'll do the on-site portion. 2 critical things about the on-site portion. One is very obvious, and one is not so obvious. The obvious thing is that we need the equipment to be fully functional. We prefer it not to have hazardous chemicals in it, because we don't have to have those to do the testing. And that all the interlocks, all the EMOs, and all the safety functions are up, available, and working. Now, the other question we get right about here is, my gosh, we've got to complete this system. How invasive is this testing going to be? A lot of the testing is going to be constructional, so your team can continue to be completing on things with the equipment while we're doing the inspection. However, at the end of our on-site, we have to have tested all those safety features and interlocks, the EMOs, all the guarding. We also have to verify the electrical side of the equipment. So you really need to be mostly done with that stuff. In fact, mostly done really means you got to be done with it, or we'll have to come back out, which stretches your delivery time. Now, the other side of it, which might not be so obvious, is you have to have some place for us to work. That's really important. We need to be able to put our equipment in, get it in, and get it set up and operate. And we can help you do that. So those 2 things, having the equipment available and having time and space for us to do the work. So once we're on site, what you could expect would be us to do an initial meet and greet, say hello to everyone, so everybody knows who's running around the equipment and everybody's safe and everything works well. And then we get walked through or look at the equipment with you. So you can show us or my team, me or my team, what we're looking at, how it operates, and how it's done. That first little bit should take about 45 minutes. Then we'll verify all the documentation matches the piece of equipment. You'll laugh here, but a lot of times we get a set of drawings and you turn them over and turn them back and turn them around and look at both sides, and they're not for that piece of equipment. Now that's exciting, but it doesn't get the project done rapidly. If you need help getting your documentation complete, we can recommend services that can help you, or we preferably have looked at it early enough to know that there's a mismatch. Now we've got the drawings. What we'll do next is we'll take a record of the equipment. We'll go ahead and take pictures of the nameplates, pictures of the exterior of the equipment, and then dive deep in and take pictures of every single inch of the equipment, so that when we get back to our labs, either here in Austin or Albuquerque, New Mexico, that we can be sure that we have documentation we can look at with you to understand how it's designed. Next, we'll go through and make sure that we have a constructional review. We'll look at the equipment, we'll look at how things are built. Hopefully they're built to the drawings. That's important for quality and for reliability. And then once we confirm all of that, then we'll have a punch list of items from the constructional review. That'll typically happen right after lunch. Then right after lunch, we'll quickly dive into any testing that is needed. For all equipment, we're going to need to test your earth grounds, test your input currents and voltages, and also test, temperature tests. So we'll need to be able to run your equipment at full power and see if anything's in there is overheating. And we'll do a temperature sweep of the system and be sure everything is good. Also, while you're ramping it at full power, we'll test for noise emissions and other emissions that we might have to test for, whether it's radiation, X-ray, laser. We'll do all that testing while the equipment's ramping up to temperature. We normally give it about an hour to ramp to temperature, and then if it plateaus, we're done. If it continues to rise, then we just continue to run until we get a plateau and the temperature rise. That's probably done, all that's probably done by about 2 o'clock. And then in the afternoon, we'll continue with the evaluation, comparing things, and then at the end of that first day, we'll provide you with a debriefing of anything that we found as a nonconformance, provide you with some suggested best practices for correcting those, and then we'll provide you with a list of any informational requests we have. So for example, on this trip I just came back on, there were two pieces of two subcomponents in the electrical enclosure that didn't have the markings I was looking for, and the team was able to quickly go back to those suppliers and get updated details and include the new revved part in their next build. So at the end of that first day, you'll have a list of things to work from. On the second day, we'll dive into specific hazards. So let's say you have a toxic gas hazard and we need to do tracer gas testing. Our tracer gas equipment will have arrived on site before us, as will the gases to do it, and we'll run those tests. Same for any other additional hazard testing that we do from there. At the end of that second day, we should have a complete understanding of your equipment and a complete understanding of where we are with constructional details. When we come back to the office, we'll continue that evaluation, and from there, we'll also work on any documentation details you need, labeling details, and manuals, and installation instructions. If you have to do some seismic calculations, we can either do those for you or you can do those in-house. So at this point now we have a really nice package, and we're coming to a close with your evaluation. Now, to give you timing as part of what to expect, typically for HTDS, this is a 10-day process. It's a very focused, very driven, very results-orientated process. Now, some of our clients are able to get through that rapidly because they have designed the equipment to meet the requirements. Other companies, we may take additional time helping them get through maybe adding a main disconnect, or maybe changing a circuit breaker to a ground fault circuit interrupter, or other things that might be required for their equipment. But typically we see these projects close in 20 to 25 business days at the most. That's the best result. That means your team is focused on it, we're focused on it, and we're getting it done. If it goes longer than that, I don't really like that. It doesn't give you a good result, and we have to come back to the project again and again and again, and it doesn't really give the best result. The best result is we get on site, we understand the equipment, and we give you a quick list, and then we're out. You make the changes. Oh, this is a good point. So depending on the type of equipment and the type of changes, we can either take your documentation in the form of pictures and engineering change notices for those nonconformances, or we can come back on site, whichever is easier. Now, if it's an extremely high hazard nonconformance, we'll come to an agreement that we should be back on site. That happens very rarely, but when it does, it gives everybody good confidence that we're complete. So now we've come through the whole process to the end. What to expect at the end. You will receive a report from us detailing all the findings, the results, the test data. Those reports run anywhere from 200 to 400 pages long. Additionally, you'll get a certificate of conformity. We'll sign a certificate of conformity, and if your CMES 2 project includes CE marking, at that same time, we'll provide you with a declaration of conformity. On the bottom left will be our signature for a certificate of conformity, and on the right, you or someone from your team will sign off declaring conformity, and then you'll be complete. So this was an overview of what to expect from the process, and I hope you found value. Again, please like and subscribe, and if you have questions or comments, put them below or email me. I'd really like to see what you have to say. Thank you so much. I'm Steve with High Tech Design Safety. Hope to work with you in the future.